Was everyone able to see okay? No one is saying no. So what we're working on now is we are doing what's called the limits to measurement. So essentially what this means is this is measuring stuff and then just going into some details about why people measure things the way they are, whether there's like tolerances for it, stuff like that. Like, has anyone here ever had to use anyone ever use like a saw before? Like you measure something, cut it, and then when you take what you measured to go put it in, it's like there's just a tiny bit of gap. Has anyone ever had that problem before? When you like, let's say you're doing like a board or something like that, you go to put it down and there's just a like a hair space. That's something called that has to do with something called like precision and accuracy. So we're gonna be learning all about that. Now, really quickly, kind of before we go in though, is you're going to be seeing a lot of these different types of measurements around. Now, the ones we're most familiar with is probably kilometers, meters, millimeters, and centimeters. You're probably the most familiar with those. These other three are ones you probably haven't seen before, or if you have seen them, it's probably just been in one of these math classes, to be completely honest with you. But essentially what this is the metric system. So when you're converting, so all of this distance that you see on your screen there is exactly 1 meter. So when you see everything you see there is 1 meter. So this is 1,000 millimeters. This is 100 centimeters. This is 10 decimeters. It's 10 decameters, 0.01 hectometers, and 0.001 kilometers. That's what this thing is here, meter stick. So if you ever want to convert, let's say you want to go from it, you want to figure out how many 100 centimeter or 1 centimeter is, you could use this chart for that. And so how you use this chart is you basically, if you're going from the left to the right, so if you're going from left to right and you actually want to draw this in, you're going to be divided by 10 every single time. So you see how we went from 1 meter to 0.1 decameters? What they did was they took that number, they divided it by 0.01. If you had 5 meters and you wanted to figure out how many decameters that is, you would take 5, you divide it by 10, you get your answer, which would be 0.5 in that case. So when you go from the left to the right, it gets smaller, 10 times smaller every single time. When you go from the right to the left, it's going to get 10 times bigger. We know that 1 centimeter is 10 millimeters, right? We know that 1 meter is, because it goes 2 times over here, because it moves twice, it's going to get 100 times bigger. So 1 meter is 100 centimeters. So that's how you could use that chart there. So if we're using that chart, if you're trying to figure out this is called prefixes. If you're trying to convert these, instead of 65 kilometers, how many meters would that be? Really quickly. So 65 kilometers, if I'm turning that into meters, that means I'm going from the right to the left, a total of 3 times. So each time is times 10, times 10, times 10. That's what's happening here. So kilometers to meters is times 10, times 10, times 10. Oops. So it's going to be 65 times 10, times 10, times 10. Or you could times it by 1,000. That works too. You get 65,000 meters there, right? So that's an example of how you can use that chart. So I'll give you just like, there's 4 questions there. I'll give you like a minute or 2 just to fill these out. You do see the answers down below, but try not to use those. I just want you to use that table on the very front page. And I'm going to fire out those answers really quickly in 1 minute. Right now, we're using the metric system. Yeah, at some point in the future, we might end up using some imperial stuff, but right here, yeah, just metric. And this isn't even like the primary goal of this, to be honest with you. Yeah. Okay, so what we're gonna do is we're gonna scroll on down here. Where was I going? To page. Yes, to page 80. So we're going on down to page 80 here. So one of the skills we just need to also make sure we have, so this is just a couple of reviews before we go into the main topic, is rounding. We need to be able to round numbers. And so the ones that we're rounding here is we're rounding to the nearest tenth of a unit. I'll explain what that is, to the nearest hundredth of a unit, and to the nearest whole unit. So I'm just going to use an example here. So let's say it's so on the right side here, what I'm writing is you can see I've written a number, right? 9.8765. That number doesn't mean anything. What I want to do is I want to reference the numbers in it. So if I'm using this 0.8, the 0.8, that 8 is what we call a tenth of a unit, right? It's a tenth of 1. It's a 1 over 10. There's 8 tenths here. So in this specific case, if I'm rounding out these numbers to the nearest tenth of a unit, that means I want it to be whatever the number is, decimal something, and just one thing there. So it should be one decimal place when you have a tenth of a unit. So when you're rounding stuff up, this is something we've been practicing all year long, but what we do is we go to the right and we work backwards to the left, rounding stuff up or down as we go. If it's a 5 or higher, you round up. If it's less than a 5, you round down, or you keep it the same, right? So in this case, the 3 is lower than a 5. Everything stays the same. The 7 is higher than a 5. So that means that this 2 is going to turn to a 3. All of a sudden, I should have 567.3 here. That would be rounded it to the nearest tenth of a unit. So, Austin, what would you get for question B there? What would you get for question B? So 65.7, that's right, because the 1's lower than 5, we keep it the same. The 8 is higher than 5, so we take the 6, we move that up to a 7, you bet, 65.7. This next one here, 2.36. This 6 turns this 3 into a 4, but this 4, now we have a 4 here. That's still lower than a 5. So this whole thing is just 2.2, and that's it. And then this question here, question D. So 0.0578. What would that one be, Kim? On page 80. Question D, yeah. No, nearest tenth of a unit, yeah. Yeah, so this one would be 0.6, right? You work from the right to the left. I can see the 8's going to turn the 7 into a 9. This is going to turn, so the 7's now, sorry, the 7's now an 8. And that 8 rounds that 5 up to a 6. So you should end up getting 0.6 there. So I have one more question for you. I'm going to write it up here. What if I give you something like this? 6.0. I want you to round that to the nearest tenth. What is that? Yes, yes.
Okay, so it's 0.0578. So
yes, it is 0.06. Oh, I see what you're saying. So sorry. Yeah, so actually what this one would be, thank you for catching my mistake there. So I'm going to zoom in on this one here. I'm going to erase this one just for space. So yeah, so I need to try and get to this unit here, right? So I'm going to cross out this 8. That turns this, so this is higher than a 5, turns that 7 into an 8. Make that smaller. This 8 turns this 5 into a 6, and then you're right, because we're going to this unit, it's actually going to be 0.0 1. Thank you for catching my mistake there. Because remember, only going to this tenths unit only. So everything rounds itself up until we get to this specific unit right here. So it's a 0.1. So this number right here is the tenth, the first one after a decimal place. So it should be 0.1. Nope, just the nearest tenth. So what you got for this one? Yes. Oh, you said it was 0.06. Oh, up here? This one? Yeah. So with this question right here, so if I wanted you to round this to, so 6.0, if I wanted you to round this to the nearest 10. So if you round this one to the nearest 10th, now so that would be what most people think. Oh, it's just 6, right? It's just 6. Not quite. So remember, you were instructed. So you were instructed to round it to the nearest 10th. That's this unit where the 0 is. So you would leave this exactly how it is. Even though there's a 0 there, they've still said they want you to round that to the nearest 10th. So they keep track of that. So if it says 0 there, you're going to leave it there. If you wanted to round 6.1 to the nearest 10th, it would still be 6.1. So you need to be very precise with it. So moving on here, if I want to round something to the nearest hundredth of a unit, so the hundredth of the unit, if you're looking at this big number written up here, 9.8765, that hundredth of a unit is going to be this 0.07. It's this 0.007 up here. That's your hundredth one, right? It's 2 away from that decimal place. And so if you're rounding something to the nearest hundredth, you would eventually end up getting 92.79 here. Because now you're going to the nearest hundredth of a unit, right? So you're going 2 decimal places out. And then we also have the nearest whole unit. Now the whole unit is going to be just the number before the decimal, right? So that would just be the 9. That's it. So just 9. So with this example I had up here with that 0.6, if you were to round that, if you were to round that 6.0 to a whole number, it'd just be 6. But otherwise, it'd be whatever it's telling you to do. So if you're rounding this one to a whole number here, you'd get 2,988. So really quickly, I'll give you 1 minute. Just work on question 4-5. We'll go over the answers in 1 minute. So just do your best guess there, okay? So 1 minute, fire out as many of those as you can. Round them to the hundredth and to the whole number. So precision is the smallest unit of the measurement on your measuring device. So when you guys are driving down the highway, your car tells you in kilometers per hour, right? It doesn't tell you in meters per hour. The closest it can get is kilometers. You ever had it where, like, does anyone here have a digital speedometer? So not like one of the ones that goes left and right, like clockwise, but one of the ones that just tells you, hey, you're going 100 kilometers an hour. Have you ever had it where you go between 100 and 101? It just flicks back and forth, back and forth. If you had a more precise measuring device in there, it'd be like, oh, you're going 100.5 kilometers, for example, but it can't measure that way. It's not that precise. So whenever we're looking at measuring stuff, we also want to take into factor that there is some uncertainty when taking measures. So, for example, if you're doing a box, if you're measuring a box with a ruler marked in centimeters, and it's a little bit less than 6 centimeters, you might just say it's 6 centimeters long. But in reality, maybe it's 5.9, or maybe it's 5.94 centimeters long. So it's very hard to get everything exact, right? Because I can keep zooming in, and it's going to eventually give me a different answer. So uncertainty is the margin of error of a measurement. So how you measure that, and so this is important. So how you measure uncertainty, it's half the precision of the measuring device used. So uncertainty is half the precision of the measuring device that is used. And if you flip to your next page, you can figure out how to find that right here. So I want you to actually highlight or box these, do something with this, make this stand out. Right here, what I'm putting in red on my screen, that is how you measure uncertainty. And there's an example right here. So if you have a box with a length of 6 centimeters, what you're using to measure that with has a precision of 1 centimeter. Your ruler goes up to 1 centimeter. And it has an uncertainty of 0.5 centimeters. Where they got this 0.5 was they took the precision and they cut it in half, and that's what it is. So I'm going to zoom in here in a second. Everyone has that boxed. So I'm zooming in. I'll zoom out in a second. This thing right here. Has anyone ever seen that before? So that little symbol right here that I've circled, I'm zooming out now. That symbol I've circled is what we call plus or minus. Literally, that's what it is. It's plus symbol, it's the minus symbol put on top of each other. So that is equal to.
So it's just like a definition pattern.
Kind of. So you're on the right track. So that symbol there, that plus minus symbol, what that means is it could either be a little bit bigger or a little bit smaller. So the easiest way I can think about it is this. Let's imagine, so Kim, ask me how much it cost me to go to the movies yesterday. Ask me that. It costs me about $20, plus or minus $1. So if I say that, if I say, hey, it's $20 plus or minus $1, you know that's going to cost somewhere between $19, it's $1 less, to $21, it's $1 more. So in terms of your, hey, is it like a guesstimation? Kind of. It's just giving you a range. When you see that plus minus symbol, it means that the true figure lies somewhere in between that. So so if I'm going into this specific example here with a box of 6 centimeters, precision of 1 centimeter, and an uncertainty of 0.5 centimeters, if that's the case, you can see right here, the box is going to be 6 centimeters plus or minus 0.5 centimeters. Which means the box is between 5.5 and 6.5 centimeters. So that plus or minus means is I'm not sure just how exact my measurement was. The tool I have is not precise enough. People make mistakes on the air when they measure it. So you have that plus or minus thing there to give yourself a little bit of range. So that's how that plus minus symbol is used whenever you see it. So we have an example down here. So there is, so what we have here is we have a marker, we have a ruler marked in millimeters, and it's used to measure this pencil. So what's the precision of this? What's the unit we're measuring in? Without looking at your paper, what's the unit we're measuring in? We're measuring in millimeters, right? If we look at this ruler, we can see that all these little dots in between, these are all the millimeters, right? So the precision that we're measuring then would be, so we literally write it in. Precision is equal to 1 millimeter. Does that make sense where I got the millimeter from? Because that's the most exact measurement tool we've been given. So when we're measuring this pencil, if I look at my ruler, I have all those little millimeter marks. So that's the closest one I've been given. So that's the precision, but what's the uncertainty? How can I find the uncertainty again? Sorry? So you think it's not quite 6.5. So remember, what's uncertainty mean? Uncertainty means it's on your past page.
The margin of error of a measurement.
Yeah, so yeah, uncertainty is the,
Precision of the measurement.
yeah, so what we do is we take remember, to find measurement uncertainty, we're going to take half of whatever our precision was. So we know our precision here is 1 millimeter. So if I take half of a millimeter, I know that I should get 0.5 millimeters. Specifically, not just 0.5, remember, it's plus or minus 0.5. We don't know exactly if it's a little bit bigger or a little bit smaller. If I zoom in on this, it's very hard to figure out, if I go up here, maybe my line wasn't very straight. We have this little margin for error here. That's what that means, that plus or minus, the true length of the pencil is somewhere between here. So let's work on question B together. So someone tell me what I do for question B here. Again, without looking at your paper. So I want to measure the precision and uncertainty. So what's my precision? Kilometer, yep. Specifically 1 kilometer.
Are we gonna put a kilometer or- Almost the same actually, never mind.
Yeah. So for question B, the precision is 1 kilometer, right? So what would be the uncertainty? Meters? Not quite. We keep it in the same unit of measurement. Technically, yes, but. So remember, how do I figure out uncertainty again?
Half. Half of the.
Yeah, half the precision. So half of 1 is 0.5, and I keep it in the same units of measurement. So I think what you were saying, Tyson, was 500 meters. Technically correct, but they want you to keep it in the same units. I mean, I know that's kind of annoying, but I got it right. You did. But they want you to keep it in the same units just because that's the language you're going to be expected to have to do. Yeah. So 30 seconds. I want you to do question C, question D without looking at those solutions. So 30 seconds, put precision, uncertainty for question C and question D.
What are we supposed to do, C and D?
C and D, you betcha.
We do answers.
It does, but do it without looking at them. Okay, so question C, what's my precision? Austin? So remember, precision is it's our measuring unit. So how are we measuring the temperature right now? In question C. Celsius, yeah. So specifically, we're measuring it to the closest we can get to it is 1 degree Celsius. So that would be my precision there. So we have it at 1 degree Celsius. And then my uncertainty Aiden?
Is 0.5 degrees Celsius?
Yeah, 0.5 degrees Celsius, yeah. Annika, for question D, what would be my precision there? So what unit of measurement am I using? For question D.
Hours.
Oh,
Oh, was that not? week?
no.
Sorry.
So what's our unit of, what's our precision there? What's our unit of measurement there, Annika? For question D. How are they measuring how long it took them to drive? It's by our hours, right? So it's by hour. So in this case, our precision here would be in by an hour. So we're doing it by about an hour then. And so then what would be my uncertainty? Anybody? Oops. Yeah, 0.5 hours, you betcha. Mhm. And remember, for all of these uncertainties, you should have this little plus or minus in there, right?
That's, it's like the same.
For those ones, yes. But when we get to some later stuff, not quite, when we put it to specific examples. So you can see this question 9, 10, and 11 here on page 84. So there's 3 questions there. I'm going to give you 3 minutes to work on those, and then we're going to apply this to specific things. So I'm going to give you a hint though. All of your answers for that are going to be, it's going to involve 0s, 1s, and 5s. It's going to involve nothing else. So for all these questions, you're going to have either a 0, a 1, or a 5. Of course, there'll be a decimal point as well. So 3 minutes for 3 questions. So measure and precision, we're looking for 2 things. First, what's the unit that's being measured in? It's being measured in centimeters. So I'm just going to put that there. And then what's the most precise amount? I can see that it is being measured off of centimeters. So that is just going to be a whole number. It's just going to be a single centimeter, right? It doesn't go down to 0.1 centimeters. It's not going to millimeters. It's just sticking to centimeters. If you put meter there, which is a very common error, don't worry if you did that. Remember, it's a meter stick. That's the length of the measurement. But this meter stick is broken off into centimeters itself. You're always going down to the smallest level of measurement. So that is my precision. Now for my uncertainty, remind me, how do I find uncertainty again? Half of the precision, right? And so half of 1 centimeter is 0.5 centimeters. And I don't just put 0.5 centimeters. I put plus or minus 0.5 centimeters. You want to get in that habit, right? Because I might be off by a half centimeter when I go to measure something. I don't know whether I measured it too long or I measured it too short. So that's what that plus or minus means. I'm unsure if this is the exact perfect measurement. If, every scientist in the world could reproduce this. Let's make some stuff bigger, actually. There we go. So question 10 here. So what's my precision here? First off, what's my unit of measurement? Oh, so what's my, sorry, so like by unit of measurement, I mean, is it being measured in like liters, centimeters? Yeah, it's kilometers in this case. Specifically, kilometers. Perfect. So I have my unit of measurement, and now I need to go to the smallest units of it. What's the smallest unit it's measuring? Tenth of a kilometer, right? And so a tenth as a decimal is just 0.1, 0.1. So my precision in this case is 0.1 kilometers, right? A really common error here would be people just put 1 kilometer. It's not 1 kilometer, it's 0.1 kilometers. And then my uncertainty, I just take half that, right? So half of the 0.1 kilometers is going to give you 0.05. And you put plus or minus, right? So 0.05 kilometers. We keep everything the same units. And then finally, for question 12, what's my precision there? Or sorry, for question 11. What's my precision for question 11? Degrees? Yep. So that's my unit. And then what's my smallest position? The tenths, right? So it's the tenths, it's after that decimal. If you're ever unsure, just look at the rightmost digit, right? So this is 0.8. So this 0.8 here, that's in the tenths position, which means we're measuring by every 0.1 degrees Celsius. That's how closely our thermostat can measure. And what's my uncertainty with this whole thing then?
0.05.
0.05 degrees Celsius, you bet. And not just 0.05, it is plus or minus 0.05. So plus or minus 0.05. So on the next page here, so I told you this is ones that you're only dealing with ones, zeros, and fives. When you start applying these to problems, that's when it gets a little bit more interesting. So think about those Culligan jugs, for example. There's like 18.9 liters in those. So the precision there is it's by a tenth of a liter. The uncertainty there would be 0.05 liters. So when we're measuring, so if I wanted to figure out exactly how much is in there, you have to start using that logic with the number they give you. So if you look at example 5 on question 85, so I recommend you highlight this stuff just so you know what to come and look to. And Lindsay, I think get that. Yeah, I got your text. Perfect. So if I'm looking at example 5 on page 85, there's an example here where they are mixing juice in a jug marked in quarter liters. So she measures it out to be about 2.5 liters. So if we want to write the measurement of this jug in this form, which is measured value, what's my measured value? What did they measure this at? How much is in the jug? 2.5 liters. So measured value is exactly what it tells you it is. Yeah, it's 2.5 liters. And then it's plus or minus my measurement uncertainty. So my measurement uncertainty, so what's the precision of this now? So half of 0.5, that's exactly it. Yeah. So now I'm taking that, sorry. Sorry, so not quite actually, not quite. You're super close. So it's not just 0.5. Remember, so when we are looking at measurement uncertainty, we're taking our precision. So when we're looking at the precision, what's the precision of this whole thing, of these jugs? What's the smallest amount they measure it in? They measure it in quarter liters. You're not supposed to know, and that's okay. So they measured it in quarter liters, right? So their unit of precision here is 0.25 liters. So that's a unit of precision. So for my uncertainty, I need to take this and cut it in half, right? So my precision unit here is 0.25 liters, quarter liters. That's what they've told me it is. And then I'm just going to take that, I'm going to chop it in half. So 0.25 divided by 2. All of a sudden I should get 0.125. So it's plus or minus 0.125 liters. Let me So that's what this is. So what they're saying here is that, hey, I have a jug, it's filled with juice and it's about 2.5 liters, but it's really hard for me to tell, right? If you ever tried to fill something up exactly, and you're trying to tell, like, is that directly on the line? Is it above? Is it under? That's what she's doing here. So this is her margin of error. So if we're trying to figure out the range of volume in these liters, what that means is, if I take this 2.45 liters, so 2.5, and I take away now, so now I'm going to go from the smallest to the biggest. I'm going to figure out what's the minimum amount that could be in that jug. So I already know I have a margin of error, which is 0.125 liters. So it's 2.5 minus this, you should get 2.375. So I know the range of this jug is it needs to be between 2.375. That's the least amount that could be in it. Or it could go up to, I take my 2.5, I add on that 0.125. That's where the plus and minus comes into play here, right? I am literally taking what I know I have, or what I think I have, and adding this, and then subtracting it. I'm trying to get the range here. To 2.625. So this is my possible range of liters in the jug. There's between 2.375 liters to 2.625 liters of juice in this jug. That's what that's saying when it asks you for the range. So I got those numbers by literally taking my stuff up here. I took this 2.5 and I added and subtracted my measurement uncertainty. So let's try one out together here. So if you're going to head on down to page 85 on the bottom of it, we have a different example here. So first off, what do we know about this question? I know he's measuring height in 1.75 meters, and his tape measure is marked in centimeters. So first off, let's figure out my measured value. What's my measured value? Sorry? Not quite. So remember, measured value is, here's what it is. The last one was, your measured value was 2.5 liters of juice. So my measured value in this case is 1.75 meters. You betcha. Now I need to add on my measurement uncertainty. So this is what we were doing earlier before the break. We were figuring out measurement uncertainty. So how do I figure out measurement uncertainty again?
Smallest value of the 0.75 meters, right?
So that's precision. Yeah. Again, if you're ever unsure, that's how we display it. So if you ever want to find measurement uncertainty, if you ever want to find that measurement uncertainty, remember, you can take half the precision of the measuring device used. So how you find measurement uncertainty? Take the precision, cut it in half. So if I'm going back down to this question, what's my precision being used in this 1.75 meters measured in centimeters?
These would be 1750.
So you're super close. So remember, so my precision here is I'm measuring something in centimeters, right? So what's my smallest unit of measurement if I'm doing centimeters?
1 centimeter.
1 centimeter. Perfect. Yeah, so that's what it is. And then, so that's my precision, which is 1 centimeter. And then I find my measurement uncertainty. So I'm putting MC, measurement uncertainty, MU. It's just half of that, right? So what would be half of 1 centimeter? 0.5 centimeters. You're right. So perfect. So I now have, so I'm going to put that in here. So 0.5 centimeters, plus or minus 0.5 centimeters. That's my measurement uncertainty. Now I'm not quite done because does anyone see the issue here? I'm just gonna type it in. That's the issue. Yeah, meters and centimeters. So 1.75 meters plus or minus 0.5 centimeters. So you're absolutely right. That's the issue right now is that I have something in meters and centimeters. We want everything to be in the same unit. So what I need to do is I need to take my centimeters, turn it into meters, because this is my given value. So I need to turn what's not in meters to the meters. So in this case, if I want to turn a centimeter into a meter, what do I need to times or divide that by? By 100? Absolutely. Yeah, so if I'm turning a centimeter into a meter, I'm moving to the right twice. I'm going to divide that by 100. Where am I? So I'm going to divide this by 100 then. So let's take the same thing. So 1.75 meters plus or minus. So it's 0.5 divided by 100. 0.005. So 0.005 meters. So now everything's in the right units. That is my final answer there. So I took my measured value, I found my measurement uncertainty and put it in the same units. So now I want to find the range of this, right? So how did I find that range? The question above on the example.
And then you were like.
Oh, so that's how I find the measurement uncertainty. So how I find the range of something. So remember, if we go back to this jug example, I took this 2.5 liters and then I literally. Oh, okay, yeah. So then I added and subtracted my measurement uncertainty. So I'm gonna do the same thing here. So I'm gonna take my 1.75. Oops. So I'm going to take my 1.75 meters and I'm going to add and subtract. Sorry? Let's find out. So yeah, so take this, so take away that 0.005. So it's 1.745. And then if I, this is A. Oh, sorry, this is B. Thank you. Thank you, Kim. Yeah, so it's 1.745 meters to 1.755. So all I did was I took that unit of measurement and I added or subtracted my uncertainty. And that would be my range. So his height is somewhere between here. His height's somewhere in between this measurement.
So it's pretty accurate.
It's pretty accurate, yeah. Okay. So we're going to do one more together here. I want you to try out question 13. And if you finish that, you can move on to 14. So try out question 13, 14. I'm going to give you a hint though. This one's going to the nearest 10 centimeters. So this is kind of a new one. It's at 10 degrees. Thank you. Yes, 10 degrees. Oh, I'm stuttering so much today. It's in the 100th place, right? So this right here is in the hundredths place. So technically, if that's the case, so we have our decimal here, right? We have decimal, it goes 1 and then 2. So this is the precision of the measurement that they use. And that makes sense, right? This is looks like it's the Olympics, right? Or like a really competitive sporting event. So they measure it as accurately as they can to a hundredth of a second. So that's their precision that they use. Which means when this swimmer crosses that finish line, there's a range of error, right? It could technically be past this in another decimal place. They could break it up even further. So what's the range of her possible times? So to get her range, remember, I need to know what that measurement uncertainty is. So what would my measurement uncertainty of this be? 0.005 plus or minus 0.005. Sorry, 0.005 seconds. So that is my measurement uncertainty. So that's how exact they have to be for these big sporting events, right? So if that's the case, what would my range be for her actual time? We know she did 2 minutes. Ooh, so it'd be all of this, but we're looking at this 12 specifically. So it'd be, we know it's going to be 2 minutes, 20 seconds. So 2:20, and then you said 0.12 or 7.
I'm 17 or 17. 17 or 7.
Oh, 0.17. Oh, so I see what you're doing there. So we're not adding on to that. We're going one space further, right? Because it's 0.005. So technically this would be 12.115. Remember, to 220.125 would be her range. So her actual time was somewhere between this 2 minutes, 20 seconds, and then this many milliseconds. So when she crossed that finish line, her time was somewhere between there. They don't know exactly what, right? They don't know exactly when she crossed that finish line because they can only measure it up to 0.01 seconds. So what you guys can do for now then, just to kind of practice, I want you to skip ahead to page 89. And I want you, 89. And I want you to just work on some of these questions here for now. So questions 1, 2, and 3. We'll come back to this in a bit. I know it's a lot. We're just kind of making up for some lost time for last week. So you head to page 89. I just want you to work on those for the next couple minutes. We will come back to this stuff tomorrow, okay?